Okay, one thing you have to be careful about when you're composing functions is the domain of the final function, because sometimes it can be a little deceiving. Now, the two things you need to look at when you're finding the domain of the composite function is the domain of the function that you're plugging into the function. So when we look at the name, you need to look at the second one because that's the first thing that we're plugging into. So we need to see, is there anything we're not allowed to plug in that? And then you look at the final function and see there. Okay, so here we're finding f composed with g of x. And the first thing we need to do no matter what is look at the domain of the function we're plugging in, g of x. And here, x squared minus 2 is a polynomial. We would never be dividing by 0 or taking the square root of a negative number. So the domain of g of x is all real numbers, or negative infinity to infinity. Now, we actually need to find f composed with g of x. Remember, my recommendation is start with f and write it out with parentheses where there's an x, and then plug in g of x. Okay, so if we distribute, we'd have negative 3x squared plus 6 minus 1. So if we simplify that, we get negative 3x squared plus 5. And again, that's a polynomial. So we don't have any domain restrictions there. The domain would be all real numbers. So our final domain of f composed with g of x would be all real numbers, or negative infinity to infinity. Okay, so one thing you can be sure of, if the domain of both of your functions is negative infinity to infinity, at the very end you just need to make sure you're not dividing by 0 or taking any square roots of negative numbers. Okay, let's look at this next one that'll show that you do have to look at that second function. So here f of x is equal to the square root of x plus 3, and g of x is equal to x squared minus 3. And we want to find g composed with f of x. So notice we're always going to look at the function that we're plugging in first, f of x. So here f of x is equal to the square root of x plus 3. And remember, with square roots, we need the radicand, the thing under the square root. So we need x plus 3 to be greater than or equal to 0. So if we subtract 3 from both sides, that's going to tell us that x has to be greater than or equal to negative 3. So no matter what now, we know that the way these functions work, if you think about machines, the first thing we'd be plugging it into is f. And if we plug anything in less than negative 3, we would already break the machine. So no matter what now, we know our domain can't be bigger than, we can't have more than, x is greater than or equal to negative 3, which would be negative 3 to infinity. We're now going to look at the composite function, and if there's anything else we have to leave out, then we will. Okay, so let's look at g composed with f of x. Okay, and that will be, so we'll start out writing g with parentheses, x squared minus 3, and plug in the square root of x plus 3. Now here's where something a little interesting happens, because for the final function we can simplify it, although we have to remember that original domain. A square root and a square cancel each other out, so here we get x plus 3, the square root and the square cancel each other out, and then minus 3. So this just becomes x. Now that's a function whose domain is all real numbers, and this is where we have to be really careful, because since we already know it can't be more than negative 3 to infinity, we'd have to say that g composed with f of x is equal to x. We'd say for x greater than or equal to negative 3, or you could write it for x in the interval from negative 3 to infinity. So our domain, we can't say all real numbers, even though the final looks like it would be. We still have to use from negative 3 to infinity.